Megan McMahon, and I'm a clinical psychology student at the University of Texas at Austin. Today, I'll be presenting our poster on rest activity rhythms and white matter across the lifespan. And thank you so much for showing an interest and taking the time to attend this virtual poster presentation. I hope it is worth your time. Without further ado, let's go ahead and jump in. So rest activity rhythms are circadian-driven activity patterns that reflect things like when we tend to go to bed, wake up, how much we nap, how fragmented our sleep is, and when we tend to be most active during the day. So some prior research has found that having greater stability in day-to-day rest activity patterns is associated with better health outcomes. So in aging, greater rhythm stability has been associated with better cognitive performance as well as reduced risk for things like dementia, cardiovascular disease, and depression. So given the connection between rest activity rhythm stability and cognitive health in aging, we sought to investigate whether there are any neural correlates of rest activity rhythm stability which might underlie that relationship. We were also interested in whether that relationship is present in young adults and then how it might change across the lifespan. We examined white matter integrity by analyzing diffusion tensor images from 103 subjects, including 46 healthy young adults and 57 older adults. We focused on fractional anisotropy, which is a measure of how constrained water diffusion is in a given direction in the brain. So higher fractional anisotropy values have been linked with greater structural integrity of the white matter, and then as fractional anisotropy decreases, it's been associated with atrophy of structural barriers such as cell membranes and fiber tracts. So now looking at our results comparing older adults to young adults fractional anisotropy, we see in red that young adults by far and away have greater fractional anisotropy compared to older adults in a number of different regions across the brain. Rhythm stability was computed based off of 7 days of actigraphy recording and was calculated by fitting a modified cosigner model to reflect subjects' typical 24-hour rest activity rhythms. We use rhythm amplitude as a measure of this day-to-day stability. Now, when we look at age group differences in rest activity patterns, we did not find a significant difference in group mean of the amplitude metric. However, we do note some increased variability within older adults in rhythm amplitude. We did find significant age group differences in interdaily stability, which is a measure, again, of the day-to-day stability of rest activity patterns computed with non-parametric means. We also found that older adults had an earlier phase onset, meaning that they had earlier times of peak activity. Using tract-based spatial statistics, we performed voxel-wise permutation inference with threshold-free cluster enhancement to identify significant reasons associated with rest activity rhythm stability. So, our results revealed a main effect of rhythm amplitude on fractional anisotropy, with significant clusters primarily in the corpus callosum, as well as the bilateral anterior corona radiata and the right superior longitudinal fasciculus. This is really interesting because the corpus callosum has been previously found to be sensitive to acute sleep effects like sleep spindle density as well as sleep deprivation vulnerability. So here we see that the corpus callosum may also be sensitive to more global subtle day-to-day patterns in rest and activity. Interestingly, we did not find a significant interaction effect with age groups, suggesting that the relationship between rhythm stability and white matter integrity is relatively stable across the adult lifespan. With that, that concludes the main takeaways from this poster presentation. I'd also like to acknowledge our funding source. This was funded by the NIH National Institute on Aging, and a big shout out to all of our RAs who helped so much with this project. I'd really love it if you have any questions. Please feel free to reach out to me either through email or through Twitter. Thank you again for taking the time to attend this poster presentation.